Hello everyone, this is Mrs. Logus and I'll be going through numbers 25 to 35 on your cumulative review packet number 8. So if we start here with number 25, it's asking us to write these numbers in scientific notation. And so in order to be in scientific notation, we need a number, this first number, to be between 1 and 10. And so it's a number times 10 to a particular power. So an example of something in scientific notation is 2.5 times 10 to the third, because this first number is between 1 and 10, and we have times 10 to a power. So if I wanted to move number 25 to be in scientific notation, it has to do with where the decimal point is currently, and we need to move the decimal point to a place where this number becomes between 1 and 10. So when you don't see a decimal place, I would always assume it's the end of the number. And so if I move this decimal over 1, 2, 3, 4, 5, 6 positions, my number is now at 52, which is still not between 1 and 10. But if I move it one more over 7 positions, then this number becomes 5.2 times 10 to the something. And that something is how many times I moved the decimal place. Now, because this number is large, that means we're going to have a positive exponent. So my answer will be 5.2 times 10 to the positive 7th power. Unlike number 26. 26 originally is a smaller number, or a number below 1. So if it's a smaller number, I'm going to eventually have a negative exponent. So my decimal's here, and I need to move it so this number is now between 1 and 10. So if I move it over 1, 2, 3 positions, I'm at 0.17, which is not there yet, but if I move it over one more, 4 positions, I'm now between 1 and 10, because with the decimal right here, the number is now 1.7 times 10 to a particular power. Now, because my number is originally small and I moved 4 positions, my exponent would be negative 4, not positive 4. Now for the record, the answer could be written without the x. It could be written with a multiplication dot instead. So you could have 5.2 times 10 to the 7th like that as well, if you want. Number 27 and 28 are asking you to do the opposite thing of 25 and 26. We want to write these in standard form, which really means we want to write it as a regular number, not in scientific notation. So 27 is given in scientific notation, and the decimal place is currently right here. If my exponent is a positive exponent, that means that my number was originally large, which means that my decimal place has to move 1, 2, 3, 4 positions to the right, because the number needs to get larger. And if I moved it 4 positions, it looks like I have 1, 2, 3 zeros as placeholders. So this number written as regular number is 23,000. Number 28. Because I see a negative exponent, that means this was originally a small number, a number less than 1. So right now, my decimal place is between 3 and 1, but I need to move this 1, 2, 3 positions to the left. And this time, I have 2 places for 0 placeholders, so my original number was 0.0031. Numbers 29 and 30 are asking you to not only do scientific notation, but also to follow exponent rules. So if I look at 29, I notice that I have no powers on the outside of either parenthesis. So just like exponent rules, we could take the parentheses off. What we also would notice is that these 2 pieces have the same base of 10, which means I could apply exponent rules. When I multiply 2 bases that are the same, I really add the exponents. So I'm going to write times 10 to the 8 plus negative 2 power, which is really times 10 to the 6th. Now this other part, 1.2 and 3.0, are not like bases. So when I see 2 numbers that are the same, the problem's really just asking me to multiply 1.2 times 3.0. And if I do that, I end up with 3.6 times 10 to the 6th. And I need to ask myself before moving on if this number is in scientific notation. Well, is this number between 1 and 10? Yes. And is it times 10 to a power? Yes. So my final answer is 3.6 times 10 to the 6th. Number 30, if I do the same process, again, I notice that I have something times something else, no powers on the outside, which means that, again, I have like bases of 10, and I can add those exponents. So I have times 10 to the 32 plus 5 power, or times 10 to the 37th power. Just like the previous example again, 2.7 and 6.0 are not the same base, so the problem is multiplying, so you're just going to multiply these as regular numbers, 2.7 times 6.0, and this time if you do that, you get 16.2. Now alas, 16.2 is not in scientific notation. So what we need to do is focus on this 16.2, change this to having scientific notation, then eventually combine it with this. So if I focus just on this part and I write this in scientific notation, I would have to move the decimal over 1 to the left. And because 16.2 is larger than 1, I know that the exponent it came from had to be positive. So because I moved it one position, this is 6.12 times 10 to the first. And that is still being multiplied by 10 to the 37th power. So these again are like bases. When I have like bases, I add the exponents. So my final answer is 1.62, which is now between 1 and 10, times 10 to the 38th power. Number 31. This time we're dealing with scientific notation divided by scientific notation. And if you think about what we did during exponent rules, if two things had the same base, we ended up subtracting the exponents. So this is really times 10 to the 8 minus 2 power, or times 10 to the 6th. 4.0 and 2.0 are not the same base, so the problem asks us to treat them like normal numbers. And the original problem is dividing, so we're going to divide 4 divided by 2 and get 2. Is 2 between 1 and 10? Yes. So this is my final answer in scientific notation. Number 32, I have the same base again here with the tens. So just like number 31, I'm going to subtract the exponents. 10 to the negative 2 minus 3 power, which is times 10 to the negative 5th power. This time, again, these are not the same base, so I'm going to divide them as regular numbers. But if I do 1.5 divided by 2 in the calculator, I get 0.625. And this time, 0.625 is not between 1 and 10. So I need to change this number to something in scientific notation. And if I do so, I'm going to move the decimal 1 over to the right. And this number is less than 1 originally, which means that my exponent has to be negative because this number is less than 1. We moved one position, so the exponent would be negative 1. Now these have the same base. Two bases that are the same, if multiplied, we add the exponents. So my final answer will be 6.25 times 10 to the negative 1 plus negative 5, or negative 6th power. The last circumstance with scientific notation has to do with raising something to a power, which is another exponent rule. So what we're going to do is raise both the 2.1 to the third and the 10 to the negative second to the third. And when I do that, I multiply the exponents. Right now, there's a secret little 1 there on the 2.1. So I have 2.1 to the 1 times 3 power times 10 to the negative 2 times 3 power. That's really 2.1 to the third times 10 to the negative 6th. If I use my calculator and I plug in 2.1 times 2.1 times 2.1, I get 9.261 times 10 to the negative 6th power. Lucky for us, 9.261 is between 1 and 10, so my answer is in scientific notation. And I don't know if any of you have been wondering this, but whenever you have a negative exponent in scientific notation, you leave it. You do not have to flip the exponent because in scientific notation, it's good to have the negative exponents so that we know it's a small number originally. Number 34, if we do this one the same way as 33, both of these bases in here are being raised to the second. There's really a 1 there. So we have 5.25 to the 1 times 2 times 10 to the 12 times 2 power, because that power is on the outside of the parentheses. So we have 5.25 to the second times 10 to the 24th power. If in the calculator I type in 5.25 times itself, I get 27.5625 times 10 to the 24th. Now this time, this number is not between 1 and 10. So if I'd like to change this to something in scientific notation, I move the decimal over to the left one time. Because this number is much larger than 1, that means that in scientific notation, my exponent would be positive. So I have 2.75625 times 10 to the positive first, because I moved it over one position, and the number is bigger than 1. And that is still being multiplied times 10 to the 24th power. Like bases, I add my exponents, so my final answer is 2.75625 times 10 to the 25th power. Last problem is a piecewise